Hello everyone, I'm Will, a fourth year computer engineering student with an interest in web and mobile application development.
And I'm Marcin, a fourth year computer engineering student with an interest in developing new and innovative engineering ideas. And we're Group 9. Our project is on operational transformation. My role in this project involves investigating and developing an algorithm that solves the problem of keeping documents in an online, collaborative, real-time coding environment consistent. I'm also responsible for arranging team meetings and ensuring that the team is up to date on the latest project requirements.
And my role in this project involved realizing the developed algorithms into a working code that can be tested for correctness. I am also responsible for developing the project plan and managing the project stakeholders.
As fourth year engineering students, both of us have participated in what seems like countless course projects. Throughout our 4 years, we've taken notice of some of the most common approaches to large classroom programming projects. Invariably, these large projects involving multiple team members in the classroom environment have been handled in one of three ways. First, taking turns, which suffers from slow development time. Second, working independently and then combining, which often leads to the problem of incompatible code fragments. Finally, Git repositories, which we've only rarely seen. This option is not viable for beginners, especially for first-year students. In reviewing these approaches, we thought to ourselves, isn't there a way we can do this better? Why not have a simple, easy-to-understand approach that allows for online, real-time collaborative code editing? This technology already exists for text documents, the most famous being Google Docs, but nothing really satisfies the need for online, real-time collaborative code editing. This is what got us thinking about potential solutions, and for the purposes of this ENG4000 final project, we've decided to work on a major component of that solution, which is operational transformation.
Some of the largest tech companies rely on operational transformation to keep consistency between documents. While companies such as Google and Apache implements operational transformation, there isn't an easily accessible implementation out there on the market. Our business goal is to allow software companies easy access to our implementation of operational transformation platform, and the charge will be a fee based on their network bandwidth. Our objective is to make it fast, usable, secure, and provide support for source code documents.
So what is this operational transformation we keep talking about? Well, to understand that, let's take a look at the problem operational transformation addresses. If two or more people are collaborating on an online document and each presses a key at approximately the same time, then due to the latencies, it's quite possible that each collaborator will see the effects of the key that they pressed first, followed by the effects of the keys pressed by the other collaborators. This scenario results in each collaborator having a final document that is inconsistent with what his or her peers have. The solution to this problem lies in transforming the operations to achieve consistency. As seen in the example figure, imagine two collaborators begin with a document that has the characters A, B, C. The collaborator on the left decides to add the character X at index 0, and at the same time, the collaborator on the right decides to delete the character C. Without operational transformation, the first collaborator will end up deleting the wrong character because after they prepend X, the character C is no longer at index 2. What needs to happen instead is that the first collaborator performs a transformed version of the delete operation, which deletes the correct character at index 3. The second collaborator doesn't need any transformations in this case, because after deleting the character at index 2, then prepending X leads to both documents being consistent. In this demo, we will have two developers code the famous 99 bottles of beer problem. This problem can be intuitively partitioned into multiple parts. Will and I are working on those parts at the same time, despite being at different locations.
To implement operational transformation, we use test-driven development, a software development process that relies on repetition of short development cycles. We write automatic test cases that defines what functions we want. Then we write the minimum amount of code that passes the test. Finally, refactors the new code to acceptable standards. This way, we can ensure 100% of test coverage and bug-free codes. We also made extensive use of data structures in our project. The server aspect of the operational transformation have incoming transform requests stored in a priority queue. We used WebSocket to guarantee speed as it has less overhead than the traditional AJAX polling. We were able to make OT in our application faster than Google Doc. We also do extensive compression to ensure we can send as much concurrent requests as possible. We used SSL to make sure all our communications are encrypted and secure.
Here is our solution to the problem. Thank you for listening, and we hope you enjoyed the video.